Okay, so we'll continue now with this BNF onboarding walkthrough session. Actually, it's an introduction to a new task force in OSM, well, relatively new, called the VNF Onboarding Task Force. Is anyone familiar with that group in OSM? That's good, because otherwise it wouldn't make sense to have this session. It's an introduction to what the group is doing and how you could leverage all the tools that we can provide for people that are interested in building packages. I mean, of course, VNF vendors and providers, but also testers and people that are working with open source projects. So you will see how this group can help. Okay, so the task force, it is trying to achieve to solve a problem in an NFV world, which is to actually fulfill the NFV vision, because many NFV orchestration projects are being built to just instantiate VMs or containers, and that's it. But NFV is looking beyond that. It's actually about simplifying the operation of a virtual environment, because it can get complicated when having many VNFs, and when they get containerized, we will have a lot of operations to do there. So we're looking for automation. And in the terms of networking operations, we talk a lot about day 0, day 1, and day 2. I briefly covered this topic in the charm session, but here I will be more generic. And what we are trying to achieve in general in NFV is having unique BNF packages that you don't need to adapt infrastructure to infrastructure. We want to have a uniform model that would abstract you from any variance at the infrastructure level, so that you can use this single package everywhere. And BNF providers will give their customers, will distribute this network function as a unique package, and that would finally enable this marketplace of network functions and the vision of having this like an app store of networking functions. So for that, the orchestrator needs to be able to model a VNF in a way that it can be onboarded and covering all of these tasks. Day 0 would be instantiating the VM and making it manageable. Day 1 would be configuring the VNF so that it provides the services that the network function is supposed to provide. And day 2 would be exposing operations and reconfigurations and monitoring methods from the VNF to the orchestrator. So it's more than just deploying virtual machines or containers. It's about getting inside these instances or their managers and actually configuring them, automate the service provisioning. Okay, so this is the value that we think OSM is capable to provide, and this is the value that service providers are looking for at the end in NFV. Otherwise, many of the service providers who we discuss with that are evaluating orchestration solutions, they sometimes can't distinguish the difference between a heat orchestrator, for example, right about OpenStack, or a script that automates the VM instantiation, and NFV orchestrator, and that should not be the case. We should be providing value beyond instantiation. Okay, so any comment about this? Do you agree with this concept? Yeah? For example, I know you guys of Venmo are VNF providers, right? You would like to see many of the configuration automated, right? So that you can distribute your VNF everywhere. And beyond this, we are looking for having a catalog that can be used, for example, in OSM. Imagine you can use an OSM command to pull a VNF that is hosted at a provider of your preference. So the vendor that you are working with, they provide you a VNF that you are interested in, and they say, okay, add my OSM repository to your setup. So you add the repository and you pull the VNF, and that's ready for instantiation. Okay, so that's why OSM leadership created the VNF onboarding task force to build documentation and tools that VNF providers would be using to fulfill this vision of having unique VNF packages. So it was created this year, and a chair was elected. I had the honor to be elected as a chair of this group, and for 2 years. And our mission is to build all of this, documentation and making it easy for VNF providers to build their packages. So, sorry, I added last minute things there. So the VNF onboarding task force started like 6 months ago, and is expected to have the participation of developers, integrators, research institutions, operators, VNF vendors, whoever wants to join, whoever is interested in building VNF packages with this vision. And the main deliverables that we defined we should have were these. First of all, documentation. People need to know how to onboard VNFs, how to build packages that cover all this automation, right? And then, as a group, we need to contribute and give feedback to OSM on which features we need so that this vision is fulfilled, so this automation is possible. For example, things like making a VNF aware of the IP addresses of another VNF in an automated way so that we can auto-configure both components. And finally, having these catalogs of VNFs that is not necessary to be a single catalog that could be hosted, for example, at Etsy. It's a matter of structuring VNF repositories in a way that OSM understands, or OSM-based distribution understand. And any VNF vendor can build their public repository where they host their VNFs and give access to their customers so that they can automatically grab VNFs from there using the OSM client and APIs. So that's the deliverables we should be providing. So we are done with the first version of the guidelines. So there's a complete guide for you to use to build VNFs in OSM. We are starting to contributing some features to OSM, and the first one of them that is being designed by a member of the task force is exactly this structure that VNF catalog should have. Okay, so regarding documentation, here you will find a link to the onboarding guidelines document, which was launched in a PDF format, in a white paper format, but actually it's a live document that you can find here that will be periodically updated by the task force to cover all the information you need. So based on feedback of different people that is using these guidelines, this is being updated all the time. So you will find an introduction to VNF onboarding here. No? So what's this all about? What I just summarized. And then for example, if you want to acquire a VNF, a commercial VNF, or if you want to build your own, what are the requirements you need to grab from the, or to build as a provider, or to have clear, to deliver to your customers, so that your VNF can be successfully onboarded. What are the components of your VNF? You need to, here are just recommendations on what information you need to have at hand to build the package. So the requirements, of course, the performance requirements, what a EPA features like CPU pinning or SRIOB your VNF needs. So you need to have all this clear before building the package. What's the topology of your VNF? How will you manage a day zero with a cloud init files, for example? What do you need at day one? Do you need CLI commands to run over your VNF? Or do you need API calls to be made to your VNF to be configured? Or do you need Ansible playbooks to be run? All of this needs to be clear to configure and to operate the VNF. So here you will find all the details you need to gather before, so that you build a complete VNF package. And then we go through all the stages and how we would achieve this in OSM from scratch. So how to build a descriptor from scratch. Then how to start populating it, depending on the topology it has, how the descriptor would look like. What is an internal VLD compared to the external VLD? Here it's all clear. How do you start building the descriptor in a progressive way, so that you keep adding more and more features to it, and to cover all the day zero in this case. So it goes up to parameterized cloud init and guidelines for EPA, so how to configure or to request CPU pinning and all SROB and all the EPA mechanisms. So, and then how to test this package, of course. So this is meant for people that not necessarily are related to OSM. So we provide a basic commands so that you can interact with it. Then you have day one, and since our VNF manager, our generic VNF manager is provided by proxy charms and now native charms as well. Then the documentation is all about charms and how to build them. How building a proxy charm in a traditional way, and building a proxy charm, step by step, building a proxy charm using generators, which is another new way that applies to Ansible playbooks for now, and how to test this as well. And of course, this needs to evolve to include more use cases like native charms. And this would be day one, and finally day two, runtime operations. You will find all the documentation to not only operate the VNF through proxy charms, day two primitives, but also the monitoring thing that could also qualify as day two operations. Okay, so that's the main documentation of this guidelines document that I hope you find useful, and I hope also you can contribute to it, because we are like 2 or 3 people contributing to this documentation. But I know there's a lot of onboarding going on in many of companies. So this is open for everybody to contribute. It's a GitLab repository that's hosted by Etsy that anyone can clone and start adding contributions to it. Maybe one of the commands we put is wrong, or you have a better version or better way of building some part of the package, or you're missing some functionalities, things like that. Okay. Another thing that is very useful that we launched together with Etsy is the lab environments. So if you are a VNF provider and you probably don't necessarily have a complete laboratory set up with Openstack and open source Mano and everything connected with SIROB and all the features you need to test your VNF package. So what we figured out with Etsy, since Etsy has a Vim, an API that you're using, and it will grow, it will cover more capacity, then we propose to work together to build this environment for VNF providers. So if you're a VNF provider and are interested in building your own VNF package based in the OSM model, then you have access. You can have access to this environment. And this is you need to just go over a couple of prerequisites. First, be part of the community, which is easy and free, and then coordinate access to the Hive network. And here Jean-Luc will help you out with that, so that you can have direct access to these resources. And these resources are built from a shared OSM environment like the one we are using it, but it's dedicated to the task force. It has all the latest code in there, so because we want the latest functionality to be available for VNF providers. And that is being maintained constantly and frequently, and I mean updated frequently. Then you have Openstack Access as well, which is also this same infrastructure, but in a permanent basis. So you have your own tenant as a VNF provider and your own tenant in OSM. And you have the support also of our task force. So we are a bunch of people that help VNF providers or experimentators and just building the package and dealing with the complexities that OSM could have at the beginning. So for this, you can see more details in the task force webpage. You need to be a member of OSM to join there. And I think this resource is very relevant for VNF providers to have a way to quickly be part of a growing community, and also this catalog that we are building. And then we have the walkthroughs. These walkthroughs are examples of VNFs that used this documentation to build a package. So the first one was provided by the community, by the group. Sorry about that link there. It's valid, but it's not located in the right position. These are special documents that will walk you through real-world scenarios to apply all this documentation from scratch. So the first one is part of this same documentation, the guidelines, and it was recorded live. I mean, I took a Linux machine with OSM and from scratch built a package that after 1 hour we had the package ready and the packet core instantiated based on this package. So it describes how to build this package using, this is an open source implementation of a 4G packet core called NextAPC. And it goes over all the process of building this NextAPC from scratch. Okay. And the images are in there. I mean, we built the images because you can find documentation, of course, of the creator of NextAPC, but you need to build the images yourself. So we already built those images here. You can download the packages to see the result. You can see also the video presentation of when we launched this at first, and we went online through all the process. Okay, so we have received very good feedback about this because it helps as an example. And of course, this can be enhanced. We will have a second version that includes not only the packet core, but an emulated Inode Bs and the clients, I mean, user equipment that connects and generates traffic through this packet core. Everything is instantiated by OSM. So this will be enhanced. Yes. Is public. Yeah, can you try to? No. You can access from everywhere. It's public. Yes. You don't even need to log in as a community user. Nothing is completely public. And GitLab, in GitLab, you do need some access to start contributing. I mean, it's read-only, but if you want, and I hope you want to contribute to the documentation, then I'll just need to approve you as a contributor or developer in the repository. And then we have also in the task force people that don't want to or don't know how to deal with Markdown files, because all of this is built in Markdown. It's easier for some people to work in a Google Doc or something like that. So in this way, we had the second walkthrough example, and I'm glad to say that it is a commercial VNF brought by Telenity, by Tolga Golelsin from Telenity. And he documented all of this, but in a Google Doc, on a Word format. So all of this documentation that also starts from scratch and shares the images and everything you need to build in this case, it's an SMS gateway, an SMS platform. He documents everything here. So this will be transformed to Markdown, and eventually you will be able to find it here as well. So we will start adding more and more and more examples so that there are no excuses on how to build a VNF package that is complete. And again, it's important not just to instantiate VMs, but to do something with them and to automate operations. Okay, so how are we doing in time? 10 minutes? So what I would like to do now is to go over the walkthrough of NextDPC so that you see what you should be doing when creating a VNF from scratch. I'm not going to bore you with all the process, because that was we did in other Hackfests over the platform and build the packages there live. But just to give you a quick summary on how you would do it and how you could replicate this on your setup. So in this NextDPC, what we did first was to gather all the requirements of this packet core implementation. So we had 2 VDUs, and each VDU had its own requirements. I mean, CPU, RAM, storage, and in the data plane ones, we had EPA features like CPU pinning, huge pages, and SROB. And then we had to build a topology. So 2 VDUs with the interfaces. And here you can see that you have some external VLDs and you have internal VLDs. And that's relevant because internal VLDs are networks that you want to have as a VNF provider, you want to have control over them, as opposed to external VLDs where you depend on the infrastructure of the operator from the perspective of a VNF provider. If you are an operator, of course, you care about these external connection points, and you don't care about what's going on between the VDUs of the VNF provider. I mean, that's packaged. Anyway, these 2 type of networks reflect into networks that could look the same in a VIM. But abstracted to a VNF concept, it is important because the responsibilities between each of them are different. Whatever is occurring inside the VNF is the responsibility of the VNF provider who provides the package. The rest is the responsibility of the operator. So it's important to do that distinction. It's not the same to just for convenience put everything as external or everything as internal. And then to end with the requirements for day 0, so we had the resources, the topology, and the cloud configurations, cloud init files. Then we go to day 1. So in day 1, the example that we are adding here is a simple one. It's just to enable some interfaces, replace some parameters at the configuration files, which is a common thing, using Linux commands, because this is an image based in Ubuntu. And restarting the services, which is also a common thing in day 1. You want to start some processes, right? So we want to run these commands. As a BNF provider, I know I have to do this. I don't know how to. So, but at least I know that I need to do all of this to enable the services in my BNF. So that's the objective of this first phase of gathering requirements. And at the end, day 2, as an example, we just including that we eventually need to add routes. You could say we want to add subscribers dynamically or whatever you want to add dynamically on demand. And we are considering also to operate, to monitor CPU and memory from this BNF. So that's the BNF requirements phase applied to this example. So the second phase is building the BNF package. First, for day 0, first of all, we clone the DevOps repository of OSM, where we have some tools. And one of these tools is the generate descriptor tool that will generate this skeleton for you. And then we start to modify it and create and put our first connection points. Then, we deal with the first VDU, the second VDU. And finally, we deal with the internal VLDs and external VLDs. So everything is there documented as examples so that you can apply to your own BNFs. And then we have this usage of IP profiles. IP profiles, I'm not sure if we've seen this in Hackfest, but IP profiles let you have certain control on how the subnets will be created in OpenStack. Okay, so if you want just a default subnet, you don't specify anything. If you want a particular prefix, then you can use an IP profile and OSM will take care of it. If you want DHCP to be disabled or enabled, if you want, and this is very often used, if you want to disable a default gateway, because you don't want default gateways with all interfaces, then you put an IP profile that disables default gateway in some of the networks. Then EPA requirements. How do you enable EPA? How do you enable CPU pinning, memory switch pages? How do you enable SRLB? I had a session on this on Tuesday, right? But this is applied to a real example. How do you apply the cloud init files at the end? So, and this is it. This is all the most common things you see at day 0 onboarding. Then how do you modify your package to implement this day 1 operation? So we were talking about modifying configuration files inside the VNF or modifying starting processes, for example. So for this, we use proxy charms. And then how you include a proxy charm in a descriptor apply to this use case. How you can enable proxy charms for both VDUs and BNFs. I mean, as a BNF, you could have a single proxy charm that manages everything, or you could have per VDU proxy charms as well. That's also valid. So here, I tell you how to do it. And finally, when you have the descriptors ready, we go over the process of building the charm. So you prepare the environment, and then you create the charm, and include the layers and the metadata on all the files that we checked yesterday, and the primitives. So if you just go over this exercise and just copy and paste this, and you will understand further all the process of onboarding a BNF completely in OSM. So at the end, we have the reactive files. We talked about this as well. In the reactive folder, you have a file that will implement the primitives or the actions. And they are just Python functions. So in this case, and using methods that are provided by charms. So in this case, we are activating the interfaces and modifying the configuration files with Linux command. At the end, we create the charms and include those charms on our package. Finally, we do the same for day 2. So we have charms as well for day 2, but they are different kind of charms, defined as a descriptor as day 2, and that can be called on demand. But the process is more or less the same. And then monitoring params, that we just have had a session on that, how to enable monitoring params in your VNF. So now, how to test the VNF. Of course, you need a network service that includes at least your VNF. So here we tell you how to build it, and then you validate the VNF Ds and NSDs with a tool, and compress and create the packages. We tell you how to use a feature called additional params for VNF, which can feed the descriptor with particular parameters for this instantiation over this infrastructure that you are using. And then how to instantiate it and monitor primitives and metrics. So I've quickly summarized all the onboarding steps that you should be doing when building a VNF package from zero, and how you can instantiate that at the end and monitor it. Okay. So this documentation should cover everything you need. And of course, we have some known issues documented here as well. So we are looking for more feedback on using this documentation and enriching it so that we can implement all your use cases. Okay, so that's pretty much it. And so if anyone here, I have to stand up. If anyone here is or has contact with or is interested with a VNF being onboarded in OSM, you can leverage this resource here. If you are the owner of the VNF, then just write us an email, me or to Sylvia, requesting one of these tenants, and this will be permanently given to you until you reach the status of onboarded VNF. Then, of course, you don't need any more. And you got your package for your customers, for your demonstrations, and that will be a unique package. Well, if you know of you have, as an operator, have interest in any VNF, just tell them to contact us. Okay? Any feedback, anything you think we should be also covering as a task force for onboarding VNFs? Or any question? No? Is it clear? Yeah. Okay. Well, then that concludes my session. Thank you.